Well, you can see that this function right here, this quadratic, right, this parabola, is in vertex form, so we can read the vertex off right away, right? Where is the vertex? Well, the vertex is, right, it's the opposite of this, so it's to the right 2, and it's exactly what this is, down 4. To the right 2, down 4. So on our graph over here, I'm on the graph now, I'm going to go to the right 2, down 4. Let's put a point there. To the right 2, down 4. And now I notice that we have a 1/2 out here. So this is a compression. So when I make my movements, I'm going to take the standard movements, but then cut them in half. So the standard movement would be here. I start at my origin, I go up 1, over 1, up 1. Well, I'd go up a half, but that's awkward. So what I'm going to do is I'm going to go over 2, up 4 normally, right? You would go over 2, square it, you go up 4, but now we're at 1/2, right? Look at this up here on the function. Our scaling factor is 1/2. So I'll do 1/2 of what I used to do. So I'll start at my origin, my vertex, go over 2 and square it, I get 4, but take half of that. That'll take me down here to -2. So I'll put a point there. And then my symmetry, I'll get a point 2 units to the other side of the vertex. Then I would typically make a movement of 3, but if I go over 3, then I square it, I go up 9. That's 4.5. You know, I guess that's reasonable. Or I could go over 4, square it, I get 16. Take half of 16, that's 8. That's a nicer number, just an easier number to work with. So that's exactly what I'm going to do here. So I'm going to start at the vertex, go over 1, 2, 3, 4, and then I would go up 16 normally, right, square it, 16, but I'll cut it in half because of that scaling factor. So I'm back here, 1, 2, 3, 4, and I'm going to go up not 16, but half of 16, which is 8, way up here. So I'll put a point up there. And then by symmetry, I went 4 to the left, so now I'll go 4 to the right. 1, 2, 3, 4. Is that right? Let me be sure. 1, 2, 3, 4, up. Right here. Okay. Right there. All right. So now that's probably enough points to get a decent looking curve. So I'll draw a curve through here. Let's see what we can do. I'll come down, make it a smooth round at the vertex and up. Oh, very good. All right, and there is our graph. But now I still want to get the x-intercepts and the y-intercepts. So to get the x-intercept, I'm going to set y, well, y is g of x. So I'm going to set g of x equal to 0 and solve for x. So we're going to get 0 equals 1/2 x minus 2 squared minus 4. Now, the LCD here is 2, so multiply everything up here by 2. It'll be 2 times 0 equals 2 times 1/2 of x minus 2 squared minus 2 times 4. So 0 equals, those cancel, that's why we did it. X minus 2 squared minus 8. You know what, let's add that 8 to both sides. So I'll add the 8 to both sides, and that will put us where at 8 equals x minus 2 squared. Take square roots. Square root of 8 equals square root of x minus 2 squared. Now, square root of 8, you know, I can write that 8 as 4 times 2, and the square root of 4 is 2. I'll do it here. It's the square root of 4 times 2. Now, on this side, I'm taking the square root of the square, so I get the absolute value, right? Absolute value of x minus 2. And on the left side, I can split those up. Square root of 4 is 2, so here's where we are. 2 square root of 2 equals absolute value of x minus 2. Now I'm going to come up right here and do this. Remove the absolute value, x minus 2, and this is where you get plus or minus 2 square root of 2. Add 2 and we'll have it. So the x-intercept is at 2 plus or minus 2 square root of 2. And what about the y-intercept? All right, the y-intercept, all right, so to get the y-intercept, I'm going to set x equal to 0. And I'll put that 0 right back in here. So we are going to get g of x, or y, is 1/2 of what? 0 minus 2 squared minus 4. This is 1/2 of, now negative 2 squared is 4, and then minus 4. Half of 4 is 2 minus 4, so we're at negative 2. So let's kind of summarize things here. Where are the x-intercepts? The x-intercepts are at 2, and then how about minus 2 square root of 2 and 2 plus 2 square root of 2? Now those are supposed to be those points here. Here's 2 minus 2 square root of 2, and here is 2 plus 2 square root of 2. Those are hard numbers to see for sure. But then our y-intercept is where? At, what did we get? Let's follow it. At negative 2. All right, so we're at negative 2. Does that work? Look at the negative 2. Yeah, that one works because it was one of those points that we plotted right from the beginning. All right, so here's our graph, and here is the summary of our x and y intercepts.